This week, we share amazing ML safety papers, describe dynamics of the field of AI safety, and share opportunities for how you can work with ML safety as well. Today is October the 14th, and you're watching the Safe AI Progress Report. A new long paper describes the many ways law has solved problems of technically defining human values in ways such as imperfect generalized value specification, or law, and human oversight, judges. It describes value alignment as a theoretical ethical problem, something Joshua Bach is also pushing for, and as a multi-agent coordination and cooperation dilemma. It's worth a read. The alignment problem can be redefined as an out-of-distribution robustness problem. If the training data does not contain all examples of how a human value is carried out in the world, then how does the AI generalize beyond this training set? We usually try to solve this by transforming the training data, such as mirroring and rotating images, so we get more examples, and testing our models on data it hasn't seen. More advanced methods use neural networks to generate new data, so-called generative adversarial networks, or GANs. A new paper trains these GANs to create a more reliable representation of what we consider out of distribution, instead of just testing on other datasets. Rewards for machine learning models are defined according to a true goal we have in mind. For example, creating a sustainable business that we can profit off of. However, if we don't have a good metric to track this sustainable business, we might define something like the amount of money as the reward. When we define this imperfect reward, the AI might end up doing what is called reward hacking. A new paper defines reward hacking as any behavior on our imperfect reward that leads to reduced performance on our true goal. A reward is defined as unhackable if increasing this reward does not lead to reduced performance on the true goal in any situation. Relatedly, DeepMind describes goal misgeneralization. This is what happens in the edge cases of reward hacking, when a reward is actually correctly defined, but the behavior doesn't work when it's deployed. An example is when an agent receives reward for walking to locations in a specific order and is led by a teacher that does it correctly in training, but during deployment, the teacher walks in the reverse direction. This shows that despite having a robust reward, the model student learns a wrong behavior, such as following the expert. Quentin Pope summarizes 16 papers on inductive bias in learning algorithms, which just means how learning algorithms are biased towards specific behaviors and outputs. Notable research includes using the neural tangent kernel to visualize learned behaviors in different network architectures, analyzing stochastic gradient descent's discrete inductive biases using straightforward methods, and showing that stochastic gradient descent is biased towards selecting non-deep neural networks. Larson and Gillen summarize the mentioned neural tangent kernel research in a recent post, where they also share a paper on Gaussian processes with in-depth instructions and interactive demos of what they are. I recommend looking at it. Generally, kernels in machine learning help us redefine the input data into something that our models can understand, but here they're used for increasing interpretability understanding. Warning shots are a series of examples that indicate that we should begin taking a risk seriously, such as when an AI is able to replace junior programmers, or when it's responsible for more than 10% of the world's GDP. Some argue that such warning shots will be enough to push governments to action. However, Suarez argues that COVID-19 was a test case for such a process and describes how we cannot rely on governments for the safety of future AI. This puts even more focus on technical alignment research as the best path. However, new estimates show that only around 300 researchers work full-time in the AI safety field. This is less than 0.5% of just the job posts on LinkedIn that list machine learning as a requirement, which was 98,000 at the last count. So increasing the size of the field is very important to ensure the safety of future AI systems, and Marcus summarizes his experiences speaking with over 100 machine learning academics about safety. Luckily, people generally seem more and more open to security risks of AI, and researchers are interested in the technical discussions of the field. And now to the announcements. You will find links to each of these things in the description below. Dan Hendricks has released the latest monthly ML safety newsletter that we recommend you read if you're interested in learning more. The Center for AI Safety has released a $500,000 call for ideas to create benchmarks in AI safety. and Redwood Research calls for people to find emerging heuristics in a small GPT-2 model. Our next hackathon in ML safety is about interpretability, and you are very welcome to register your interest already now. If you wish to run a local event with support from us, click on the link in the description to write us. The AGI Safety Fundamentals releases their second course on AI safety, the Alignment 201 curriculum. Sign up for their 10-week spare time interactive course down below. And visit our page at partresearch.com to learn more and follow along here for the next update. This has been the Safe AI Progress Report, and we'll see you next week.